Just a few words before we get into this. The job is machining this down from an INT40 to an INT30. You'd think it might be quite simple. In fact, it's quite involved. Lots of lathe work, setting up, milling, welding. 2 parts. I hope you enjoy it. Welcome to Haxby Shed. It's time to take a look at this 1-inch diameter long arbor which I plan to use on my Harrison mill. I got it for free. The problem is it's an International 40 taper and the machine takes International 30. I do have an INT30 arbor for the machine. I think it's original, but it's 27mm diameter and most of the cutters I've got are to go onto a 1-inch arbor. Now you might say, well, rather than trying to machine this taper down to an INT30, why not just buy another? But when I look on eBay, they're anything from £120, £180. If you want that in US dollars, multiply that by 1.2. And it's just too much money, to be honest. When I've got an arbor here that I can use, I think I can use, I'm not going to pay that sort of money. It's got a quarter key. And in fact, I found a piece of quarter tool steel in there. So I've just ordered up a bit of 1/4 by 5/16 key steel. I could make something, but to be honest, it's cheap enough to buy it. But I found that all of the collars have actually got 5/16 keyways. Now, I don't really understand how you would come across that like that, because all the cutters have got 1/4 keyways, and yet the collars have got 5/16 keyways. I reached out to some friends. They've all pretty much come back with inconclusive answers. So it's not the end of the world. I'll probably just stick with these collars because even buying those collars is darned expensive. I mean, a 2-inch collar, 2 inches that way, something like £15 delivered just for one collar. So, I'll probably stick with that. I've checked the drawbar and it's 5/8 Whitworth drawbar thread. I tested it with this tap which I got from the Auto Jumble. It was another one of those, I'll buy this tap, it's nice to have, I will never use it, £1, and I'm using it. Not to cut a thread obviously, just to check the thread. Anyway, it definitely is 5/8 Whitworth. And then at the other end, I guess that's standard, it's 7/8 UNF, so it's a 14 TPI. So, what I'm going to do now is set this up on the lathe, and first of all I'm going to check that I can follow that taper. So just mechanically, can I get the top slide round to the right angle without bumping into something? Can I get it on the lathe? And then if I can, line it up right, if I'm going to be able to cut it on the lathe, I'll just trim a bit off this edge here and just see how well it machines. If it's going to behave itself, then I think I probably will remachine this taper. Well, it looks like I can get this in okay. I'll have to put the 4-jaw on to get this to run absolutely true. I've just dialed in 0.1 of a mil after touching off, so we'll just see how well this edge cleans. Well, that's machining nicely. It's running at 305 RPM, so I'll probably speed that up, but I might reduce the feed a bit, certainly when I'm getting down to the finishing cuts. I don't think I'll have any problem remachining this. The INT40 arbor is quite a bit more beefy than an INT30, and if you look at this dimension here at the top of the taper, an INT30 is about 1¼ inches and an INT40 is about 1½. So there's quite a bit to come off there. But that's relatively straightforward. The problem comes at this end here. So on an INT30, this spigot here is about 17mm, roughly. And on an INT40, it's more like 25. And the thread on the drawbar for the INT40 that I've got here that I'm going to machine is 5/8 Whitworth, which is just shy of 16mm. And the INT30, well, that will need to take a drawbar which is M12. So if we look at the measurements in this area a bit more closely, we'll get an idea of the difficulty of trying to adapt this. So if we look at this drawing masterpiece here, these are drawn to scale, 1:1, near enough. So this is INT30, this is the nose end of INT40. The minor diameter of 5/8 Whitworth is about 13.5 millimeters, and the major diameter of M12 is M12, isn't it? So one thing I could do is to make some sort of screw-in sleeve here, and then secure it, maybe weld round it, and then drill it and tap it M12. But that screw-in sleeve is going to be quite thin, maybe 0.75 millimeters either side. I don't know if that would work or not. What I'm currently thinking is this end of the INT40's got to come off completely, and to screw in a plug, a stub, which creates this end of the INT30, and then I can drill it and tap it in plain material, avoiding this problem of having a sleeve which might be a bit thin. Now, if I'm going to be welding this here, welding on a new end, if you like, onto that INT30, then I don't want to be machining away the INT40 down to INT30 precisely on this taper, because when I weld it, it could get distorted. So I'm just going to rough out to create an INT30 from the INT40, but maybe 1 millimeters or even 2 millimeters, you know, over dimension. That'll give me the overall shape and I can see what I'm doing. Now it might be that once I get into it, I don't have to make a complete new end for this. We'll have to see what we find. So I'm feeling my way along a little bit with this, but we'll start with just roughing it out. But I'll explain the setup in the lathe now. So what you see there is the INT40 arbor in the forejaw. It's fairly obvious, but a few things to say about it. I mean, you might have seen me machining this. It was oversized. I think it was made by the apprentice. So there was a video about that, and I learnt quite a lot doing that. You can see this is sticking out a long old way, and I've done that because I wanted to get the balance about right. So I slipped this into the forejaw until it sat level and it wasn't tipping down at one end or the other. Because although I've got this live center in there, if this was way in here, there would still be a temptation for the left-hand side, the one in the headstock, to kind of flail around. And these jaws, although they're very big and strong, they're only about that long, and I was a bit worried about all sorts of things. So I wanted to get this on balance. Now, I've clocked it up here to run as true as I can, but it's difficult with there being this keyway in there, but I think that's about right. And as I put the live center in this end, this is running off by about a couple of thou. Now you could say for roughing out that doesn't matter, does it? But in my experience, it's important to get it right on every step of the process. Because if you don't get it right and get it running true at every step, you know, when you come to do future steps, you can't get it set up correctly. You lose your reference, if you like to call it that. Now, to get this running true, I think I'm going to have to put the forejaw onto the tailstock, like I did when I machined this, to get it absolutely right. We'll leave this on to begin with. We'll machine this away. I'll actually start by machining this, which has got to come down quite a bit. And that'll give me some practice. I'll get the feel of the material. And then we'll machine this down to within a mil or so of its finished size, and we'll see what we've got here. I'll also put on a fixed steady here. You know, this is plain, this last bit here is plain, look. So I'll put on a fixed steady, because I'm certain at some stage I'm going to have to machine the end of this, means taking this away. And so I want this supported while it's sticking out. So if I put the fixed steady on from the beginning, again, I'll build up experience with that. I'll build up a feel for it. We'll start by clocking this center, see if that's running true. And yes, it is. Near enough for this, for sure. Let's move along. And you can see that's off a bit. about 2/100ths of a millimetre. So that's 2 times 0.4, which is about 0.8 thou. I mean, it's actually not bad, is it really? Let's see what we've got here. Oh, that's a bit further out, that, isn't it? Look. And then if I run up this ramp, I'll probably have to reset this. Give me a moment. That's running out about 3/100ths. So 1.2 thou. And then we'll just try it here on this plain part. And here I'm measuring 2/100ths of a millimetre again, so 0.8 of a thou. I've added a gauge that Kimber Selleck sent to me. It's a bit more sensitive. And you can see that the readings of both ends of the taper are about the same, 0.03 millimetres or 1.2 thou. Well, like I said, this is a bit experimental. I've got the fixed steady set up, happy with that. I was going to put the 4-jaw onto here, but the problem is I'm a bit short of space. So what I'm going to do is I'm going to machine this down to about 17 millimetres diameter. The taper on the INT30 will end about there, and then the stub on the end of the INT30 is going to run between about there and about there. So if I make this plain and parallel, leave this on, then possibly I can get the 4-jaw onto here and give me plenty of working space. That's the idea. We'll see. Perhaps I should just add that the angle on this top slide here was set some time ago when I was making this. Unfortunately, this hole is really deep, to about there, look. So if I machine this right down to size, which is under 17 millimetres, where there's a little neck here just before the taper starts, there's every chance this is just going to break off. So I'm going to stop at that for the time being. I'm actually going to machine this next down to size. On the INT40, this drive flange is 63 millimetres diameter, and on the INT30 it's 50. So there's 13 to come off, which is 7.5 millimetres on the cross slide dial. I'm getting a fantastic finish on that. That's at 475 RPM. So I guess the difference between this and this is just speed, because that's a ropey finish on there. These are 0.5 millimetre cuts. So as I said earlier, the dimension for this according to the spec is 50 millimetres diameter, but when I measure it on the Jones & Shipman arbor, the 27 millimetre arbor that I've got, this dimension is 54, and it's not a critical dimension, it's only this driving flange, and I think if it's good enough for Jones & Shipman, it's good enough for me. So I've actually finished at 53.9. I'll leave it like that for now. So the next thing is to try again to get the 4-jaw onto here and see if I can get this running perfectly true. And then we'll take the bulk of this taper off. I've spent a lot of time on this, chasing it round and round the chuck. This is as good as I can get it, which is 0.01 of a millimetre or less than half a thou anyway. So I'm going to go with that. I'm going to machine this here at the top of the taper down to about 33. The finished dimension will be 31.75, but as I said, I want to leave some meat onto it. And then if I can get a shoulder on there, then as I machine this taper, I can just machine down to that shoulder, and that's effectively setting a depth for me without me having to keep measuring it. I've actually machined this right down to the finished dimension here. That's 31.75, although I actually made it 31.9. And the reason I've taken it right down is because I don't think any welding I do here is going to distort it way up here. I'm taking a very cautious approach. I think people with more experience would be hacking away at this, you know, with a lot of confidence. But in my case, I'm just taking it slow and steady. Now, as I said before, it might mean I've got to take this off, got to remount it. That's a lot of work. But equally, I don't want to spend £125 or something on a replacement arbor. So I just want to get it right. Well, it's next day, and it's time to commit to a firm plan and stop messing about. So I'm going to reduce this here as far as I dare. I'm then going to hack off most of the material here for the taper, getting the taper just a little oversize. I'm going to part that off, relying on this fixed steady to hold the end of the shaft in place. I'm going to make a new spigot. I'm going to have 17 millimeters external, or a little bit over. That's giving a very nice finish. I think I'm going to take this chuck off and go back to a centre. I'm not going to be doing the finish cut here anyway just now. And the chuck's quite big, kind of gets in the way. I don't want to hit it. I've finished this taper about 1.5 millimeters diameter up on final size. You can see I've reduced here to get in. Now I've discovered that the 5/8 Whitworth thread only runs to about here, and if I was to part this off here, then it will be plain inside. I guess it's going to be 5/8 Whitworth tapping drill size, and so the new end that I'm going to make could just press into there. I need to put a chamfer on the end of here and a chamfer on the new end that I'm making, and that'll be to run a weld bead in. And when it's all welded, then I'll machine it to finish size. Well, I thought I'd try. I've machined this diameter down to size. You can see the walls are far too thin. I'm going to have to part it off. Even with this fixed steady, I'm getting quite a bit of vibration. So actually, finish machining this taper relies on me making the plug, a new end piece like this, drilling a centre into that and getting the live centre in the tailstock into it. Otherwise, I'll never get a good finish on that. That's now prepared. You can see the big chamfer on the end for the welding fillet. So I'll flip the top of this fixed steady, take the 4-jaw off with this still in it, set up, put the 3-jaw on, make the plug to go into here, press it in, and then we'll be welding it round. 1/2 inch, I reckon. For that new threaded end spigot, I'm going to use this material. It's 20 millimeters diameter, and you can see on the end there where I've done a test weld. Now I did that when I was putting a new shaft on the shaper. Now John from John's workshop, who knows a fair bit about materials and machining, said to me he thinks this has got some stainless in it. Well, I don't know how well it's going to drill and tap, but I do know it does weld extremely well. That's machined down to 17.9, so there's 0.9 to come off after I put it on the end of the arbor. That's machined to finish size, which should be a press fit into the end of the arbor. That's a chamfer for the weld. I'm not going to try and part this off because I know it ain't going to work. So I've marked it and I'm just going to cut it with a hacksaw, and then I'll turn it round and just finish this end off. Last cut. I don't think there's much chance of getting this arbor onto the welding positioner with the chuck still attached, but I'm hanging on to the hope. Right. Press fit, hopefully. well, it don't fall out, does it? It looks alright, doesn't it? But there's still quite a bit of work to go yet.